Welcome, everyone, to the deep dive. Today, we're embarking on a journey really back to the very beginning of human civilization. Just take a moment, think about the oldest material, the most enduring thing humanity has ever used to build. I mean, long before concrete or steel, way before fired bricks or even widespread use of timber. What was there? Stone. It's everywhere, often unnoticed. The curbs, the old building foundations. But it holds these incredible stories, millennia of them, connecting us way back. So, our mission today in this deep dive is to really get into the soul of stone. We're going to trace its path right from ancient quarries through the hands of master masons, incredible skill there, all the way to, well, today's cutting edge fabrication shops using digital tools. We want to unpack the art, the science, that sort of timeless relationship we have with this material. It's about giving you a shortcut, really, to understanding its impact, packed with hopefully some surprising facts and insights. It might change how you see the world around you. What can you expect? We'll just start with the geology, the basics. What gives stone its character? Igneous, sedimentary, metamorphic. Then we'll look at the traditional craft. How did they build these amazing things without power tools? The sheer ingenuity. We'll explore stone as both practical stuff and a powerful symbol throughout history. And finally, we'll tackle the challenges it's not easy stuff to work with and how the digital age is changing everything. From grand monuments to humble houses, it's a story of shaping the earth itself, creating shelter, meaning, a legacy. So let's unpack this really primal connection humans have with stone. Before we could manufacture materials on an industrial scale, stone was it, the primary building block. It was just there, solid, waiting. It shaped our earliest homes, our defenses, those first attempts at, communities.
Exactly. And what's really fascinating, I think, is how stone connects a building directly to its place, to the geology. When you see a structure made of local stone, it doesn't just sit on the land. It feels like it grew out of it almost, an extension of the earth. That gives architecture this deep sense of belonging,
Yeah.
permanence.
Yeah.
It's hard to get that with materials shipped from halfway across the world. It tells you about the landscape, the local resources, the people who work them.
Yeah, it makes it feel truly rooted, part of its surroundings. And like you said, stone isn't just one thing, is it? It's incredibly diverse, just like the landscapes it comes from. We talk about rock types, but how do those fundamental differences in how they formed actually translate into how we use them in building?
That's a crucial point. Generally, we break building stone down into three main geological categories. Each has its own origin story, its own characteristics. First up, you've got igneous rocks. These are literally born of fire, formed from cooled magma deep down or lava that erupted onto the surface. All that intense heat, the slow cooling, it creates this dense interlocking crystal structure that makes them incredibly hard, really durable, resistant to weathering, compression, tough stuff. So architecturally, that makes igneous stone great for things like structural work, paving, cladding on the outside, anywhere you need it to stand up to wear and tear, weather, heavy loads. But that toughness also meant it was a real challenge to quarry and shape with ancient tools. Took a lot of effort, special techniques. Still, that strength made it perfect for foundations, walls, bridges, things meant to last forever, basically. Imagine carving a foundation stone meant to endure for thousands of years.
Okay, so igneous is the tough guy, the workhorse. What about the others?
Right. Next, we have sedimentary rocks. These tell a story of time, of accumulation. They formed from sediments, little bits of sand, silt, clay, even old shells getting compacted and cemented together over millions of years, often at the bottom of ancient seas or lakes. This layering process is pretty distinctive. Architecturally, it often means the stone has a finer grain and these natural bedding planes that affects how you cut and lay them. Limestone is a classic example. We see it mentioned in the sources. Its formation often gives it those layers. And one really key thing for builders, especially back then, was something called quarry sap. That's the natural water inside the limestone when it's first dug out. And having that sap makes a stone much easier to work, softer, easier to cut, carve, shape. Then, as it dries out, it hardens up to its full strength. So masons use this property. It gave them a window to work the stone more easily. Pretty clever, really. Needed careful timing, though. And finally, there are metamorphic rocks. These are the transformers. They start as igneous or sedimentary rock, but then they get changed by intense heat and pressure deep inside the earth without actually melting. This process, this metamorphosis, recrystallizes the minerals. It creates new textures, patterns, often makes them denser. Marble, for instance, is metamorphosed limestone. It gets mentioned in the sources for things like the Palatine facade in Rome and those English marbles. Architecturally, metamorphic stones are often really valued for how they look. The beautiful veining, the crystalline sparkle, the fact they can take a really high polish. They're often durable, but it varies. Marble, for example, looks stunning inside, but some types don't hold up so well to acid rain outside depending on the climate. So it offers a different kind of beauty, maybe more opulent sometimes than the other types.
It's amazing how the geology dictates everything, properties, best use, even the whole aesthetic. You mentioned English marbles. Can you give us some examples from the sources? How were they actually used? Was it just fancy decoration or more practical too?
Sure. One source, the pattern of English building, mentions specific types, like Purbeck and Allwalden. Geologically, they're actually very dense limestones, but they polish up beautifully, like marble. And they weren't just used for, say, sculptures. They were used for important architectural bits that still needed to look good and last. Things like chimney pieces, steps, plinths, and paving stones. So even these more decorative-looking stones had really practical, long-lasting uses. They were chosen for their local availability, sure, but also for that specific refined look they could give to functional parts of the building.
Right, adds a touch of class even to everyday elements. Okay, so we have the stone, we understand its properties,
Right.
but getting it out of the earth, quarrying, that must have been just epic work in ancient times. How did they even do it? How did they literally unearth these massive blocks?
Well, quarrying is exactly that, digging out the stone. And yeah, in ancient times, it was incredibly labor-intensive, almost entirely human effort, simple tools, but also a really deep, kind of intuitive understanding of the rock itself. They had to know its faults, its bedding planes, its weak points. They weren't just smashing it, they were reading the stone.
I can just picture the sheer effort, the sweat. You know, reading about early mining, like in De Re Metallica, makes you think it must have been similar for building stone. Even Louis Sullivan talking about gathering field stones for his little dam as a kid. It shows that fundamental physical connection, doesn't it? Even for simple stuff.
Oh, absolutely fundamental. It wasn't just getting material. It was like an intimate conversation with the land. Early quarrying used basic tools, wedges, levers, hammers, chisels, often made of harder stone or early metals. They'd find natural cracks or drill holes, stick wooden wedges in, and then soak them with water. The wood swells up, and slowly, steadily, it splits the rock. They also used fire, sometimes heat the rock, then shock it with cold water to make it crack. It took sheer determination, but also all this knowledge built up over time, passed down. They knew how to make these basic methods work really well. And that quarry sap in limestone we talked about, crucial here. Because the stone was softer right after extraction, it made the initial cutting and shaping much, much easier before it dried out and hardened completely. This gave them a vital window, to achieve a level of precision that would have been way harder otherwise.
Okay, so they've wrestled these raw blocks out of the ground. Now the real magic starts, right? How did these early builders, without our fancy modern machines, turn them into precise functional structures? Structures we still marvel at. This is where the human ingenuity really kicks in. Let's unpack the beginnings of masonry.
Yeah, this is really where craft met necessity head on. Early masonry was all about generations of watching, doing, and passing on that knowledge. Louis Sullivan's story about his childhood dam is actually a great little insight. He said he had seen Scotchmen and Irishmen build farm walls and knew what to do. That's not just a cute memory. It shows this deep, almost instinctive understanding of dry stacking, how to fit stones, even odd shapes, together without mortar, just using their weight and how they interlock to make them stable. It's a fundamental grasp of load-bearing, of balance, learned by doing, learned from others.
And some of those early structures were incredibly sophisticated, weren't they? Really pushing the boundaries of what seemed possible with just stone.
Oh, absolutely. Look at the Etruscans. One source mentions their advanced use of stone for vaulting, making arched ceilings using voussoirs of cut stone. Those were the wedge-shaped stones in an arch, and they built with huge blocks laid without the intervention of mortar or slips. No mortar, no little filler pieces. That shows an amazing understanding of dry masonry. The precise shaping, the geometry, the sheer weight. It all worked together through compression to make a stable structure. Incredible craftsmanship and understanding of forces.
That is incredible. And arches, vaults, that's where it gets really interesting for me. How did they figure out the forces? Ensure stability without CAD programs or advanced physics. Sources like Kidder Parker talk about arch stability, voussoirs, lines of pressure, centers of gravity. It almost feels like magic, doesn't it?
Well, not magic, but definitely astonishing empirical knowledge. It was physics learned through generations of trial and error and very careful observation. The voussoirs, those wedge-shaped stones, are key, and arch works purely in compression. The line of pressure, basically the path the force takes through the arch. If that line stays within the middle third of the arch's thickness, it's stable. The arch is essentially pressing firmly into itself, not wanting to buckle or push outwards. Medieval builders perfected this. They had this visual, tactile sense for what worked. They understood intuitively where the centers of pressure were, how the forces flowed. This knowledge was gold. passed from master to apprentice. Their math might have been simple ratios, yeah, but their grasp of structural behavior was profound. They were defying gravity with stone centuries before Newton wrote it all down. And think about really challenging projects. Mark Brunel's Thames Tunnel, early 19th century. A real testament to just pushing through immense difficulty. Okay, it ended up being brickwork, another shaped earth material. But the source describes it as a long battle against almost overwhelming odds. Constant flooding, unstable ground. It just shows that whether it was stone or brick, the same principles applied. Structural understanding, human ingenuity, and just sheer grit to shape the Earth's materials into something lasting.
And the scale of medieval cathedrals, projects taking decades, sometimes centuries, that level of dedication, that collaboration, what kept those massive stone projects going?
Well, one source calls it the Cathedral Crusade. It was this amazing mix of social, economic, and spiritual drive. The church actually granted indulgences, basically, time off purgatory for people who helped build them. This channeled huge amounts of resources, money, labor into these giant stone structures. It created this incredible community energy. People felt they were literally building their salvation stone by stone. A collective act of faith made tangible. And the architects, people like Viard, they had incredible skill, immense empirical knowledge. They were often pushing the limits of what was technically possible. The sources say their learning must have been above all empirical, based on experience. But they still applied amazing mathematical precision in drawing the plans and elevations, often using simple ratios, double and half, treble and a third. So it wasn't abstract theory, but a mastery of proportion and scale learned through practice, ensuring both stability and beauty. Their designs were this blend of necessity and artistry, all realized in stone.
That idea from one of the architecture lectures about form being inseparable from structure in Gothic cathedrals, that really resonates. It says, every member is the result of a necessity of that structure. Unlike Roman buildings where you could maybe peel off the decoration, it sounds like the stone itself, its structural needs were actually dictating the look of the building.
Exactly. In Gothic architecture, the structure is the decoration. Every flying buttress, every ribbed vault, every thin column, the intricate window tracery, they're all doing a structural job, channeling forces. And their shape comes directly from that job. It makes this incredibly unified, powerful whole. It's different from a lot of Roman architecture where, yeah, the decoration could sometimes feel like an added layer. Beautiful, but not essential to the structure underneath. Gothic cathedrals are like honest diagrams of their own structure, making the stone itself the star. And this deep connection to materials also led to fascinating regional differences, like in Romanesque architecture. One source describes it being delicate and elegant in Auvergne, maybe influenced by local traditions and finer stones. But in Normandy, it was severe, methodical, scientific. Much bolder, perhaps reflecting different stone types or building traditions. And sometimes, builders just had to use small materials which could be raised and laid without. Machines, human strength being sufficient. They adapted their designs to what was available locally, what they could physically handle. It shows how geology, ingenuity, and local craft all came together.
It makes you wonder about the tools, though, to get that precision. We heard about basic spade and pick for early earthworks, but for carving those intricate voussoirs or delicate window tracery, they must have had more refined tools, right?
Definitely. The tools evolved. While a source like De Re Metallica focuses on metalworking tools, spatulas, pestles, mallets for making crucibles, it points to a similar kind of skilled craft tradition for stone. Stonemasons would have had a whole kit. Different hammers, mallets, often wood, for striking chisels without damaging them, points for rough shaping, toothed chisels for removing material more evenly, flat chisels for smooth finishes. Each tool had its job. But the real precision wasn't just the tool, it was the hand guiding it. Masons learned to read the stone's grain, predict how it would chip or break. They'd also have developed measuring tools, squares, compasses, plumb bobs to transfer designs and keep things accurate. It was this intricate hands-on tradition passed down master to apprentice. It shows that even with relatively simple tools, you could achieve incredible results through skill and patience.
Okay, so we've looked at its geological roots, how humans first learned to shape it. So what does this all mean for the look of stone, its aesthetic impact? It just feels like stone has this built-in beauty, doesn't it? Something architects have tapped into for thousands of years to create buildings that really speak to us. How did it become such a powerful medium for expression?
Well, stone's inherent qualities are just perfect for it. Its texture, the huge range of colors, its sheer weight and solidity, the way light plays across its surface. It lends itself perfectly to creating beauty. Alberti, in one of the sources, put it nicely. He said the beauty of all edifices arises principally from three things, namely, the number, figure, and collocation of the several members. Basically, proportion, shape, and arrangement. Stone lets you play with those elements endlessly. And its permanence means those aesthetic choices last. They endure for centuries. Think about Palladio. The sources say he loved the ruins, but saw only what and how he wanted. He was interpreting classical forms. He often used elements pictorially rather than tectonically, meaning he focused on the visual effect, the symbolism, maybe more than strict structural logic sometimes, to create this feeling of dignity and classical harmony in his villas. Like the villa at Mazer, with its infinite ornaments of stucco and paintings, and those prominent Ionic order columns. Stone, or materials mimicking it like stucco, were used to elevate the building, make it art, a symbol of classical ideals. It's a sophisticated game between the real material and the illusion.
And that connects straight back to classical architecture's lasting influence, doesn't it? Palladio himself meticulously documented classical principles like pedestal proportions relative to columns in Roman arches, Susa, Pola, the amphitheaters in Rome. It shows how these ancient aesthetic rules, usually expressed in stone, just keep echoing through design history.
Exactly. Stone was the main way these timeless ideas about proportion, decoration, scale were made real, made visible. They became tangible lessons for architects who came later. Stone became a language, really. A language of power, identity, permanence carved right into the landscape. You see this so clearly in grand monuments. The Parthenon, for instance, described as a monument of humanism, embodying Athenian ideals, while earlier Doric temples might convey more religious feeling, and another temple had a faint whiff of commercialism. Different messages, but all using that single rigid language of Doric architecture. Stone let them articulate these nuances with incredible impact and longevity. Or think about Rome. The Palatine Hill, one source describes how Emperor Septimius Severus built this fanciful three-story marble facade, the Septizodium. Why? Explicitly so it would strike the eyes of his people arriving from Africa, a massive monument to him. It was a calculated, strategic use of expensive marble to project imperial power and personal prestige across the empire. Stone as propaganda. And we see it again with national identity. The Gothic revival in the 19th century. England rebuilding the Houses of Parliament. Germany finally finishing Cologne Cathedral. Both countries deliberately looked back to their medieval past. They adopted this national and Christian style, using stone to make these big, proud statements about who they were, linking back to their history. Stone, history, identity deeply intertwined.
But it's not all grand monuments, is it? Stone is also the workhorse for countless everyday buildings, the ones that make up our towns and villages, often fitting so naturally into their place.
You're absolutely right. Stone's practicality shines in everyday vernacular structures, buildings shaped by local needs and traditions. Think of those Voisey cottages mentioned, with their rough-cast walls, a throwback to medieval practice. Using local stuff, traditional finishes gives them real character. Or consider quoins, those dressed stones or bricks reinforcing the corners of buildings. Often mentioned as being used for decorative effect, too. They add visual strength, a bit of detail, often signal a regional style even on simpler buildings. And foundations. Stone or masonry derived from it is still fundamental there. Building codes emphasize proper footings like needing to be 12 inches deep and 6 inches larger than the fireplace they support to spread the weight. And modern practices often require dam-proofing on foundation walls against groundwater. It just shows stone's vital, often hidden role in making sure even basic buildings are stable, durable, and healthy, anchoring them to the earth.
So it really does come full circle, connecting the building to its place, not just physically through the foundation, but through its whole material being. Looking at the bigger picture, it's way more than just looks or symbolism, isn't it? It's a direct link between the building and the ground it stands on.
Precisely. There's a source, the Pattern of English Building, that illustrates this perfectly. It lists specific English quarries, Croft, Enderby, Mount Sorrel. And it points out how local geology dictated everything, even saying things like, our lead ores are found in association with the older rocks. This shows directly how the stone underfoot shaped what people could build with. It shaped the whole look of a region. Buildings became truly local, a direct reflection of the place, the earth's gifts, and the ingenuity of the people using them. Now, despite all its strengths, its beauty, its permanence, working with stone has always had its challenges. Big ones. The sheer immense weight is a constant factor, and the high level of skill required to handle it properly, that hasn't changed either. It's a material that demands respect and expertise.
And that weight means huge structural demands, right? It's not just lifting it. The whole building has to be designed to carry it. One source highlights the need for proper lintels over openings, doors, windows. Whether they're steel, reinforced brick, concrete, or precast concrete lintels, they all need sufficient minimum bearing, like 6 or 8 inches on the masonry beside them. That's critical to spread the load, stop things from cracking or collapsing. A lesson learned the hard way over centuries, I imagine.
Absolutely. And it's not just static weight. Stone, even solid masonry, moves. Another source explains that masonry materials expand and contract with changes in temperature and moisture content. How I? So clay bricks tend to absorb water and expand a bit, while concrete blocks tend to shrink as they dry out after being made. To handle these small dimensional changes and stop cracks appearing, you need movement joints, basically planned gaps. It adds complexity to modern design, sure, but it shows we now understand stone's physical behavior much better.
So, given these challenges, how did we get from just stacking stones or hand carving elements to materials that kind of mimic stone or help us work with it? Was it a slow creep or a big jump?
I'd say it was a gradual but pretty profound evolution, driven by wanting more efficiency, more versatility, the ability to build bigger and faster. Concrete is the obvious big one. It's like stone's engineered descendant, a shaped earth material, you could say. It was a huge leap in manipulating stone's basic components. Sources describe the manufacturing starting with rotary kilns, cooking limestone and minerals into cement clinker. That gets ground up, mixed at central batch plants, delivered in transit mixed trucks, ready to pour into forms. And the science behind it is way beyond just stacking. It's about precise water-cement ratios for strength, proper curing, controlling moisture and temperature so the chemical reactions work properly. It's basically creating a castable artificial stone that can take almost any shape, dramatically cutting down the labor of cutting and lifting individual heavy blocks.
And alongside that, the tools changed radically too. From hand tools, where skill was everything, to machines augmenting or even replacing hands. Here's where it gets really interesting. How has modern tech truly changed how we work with stone today?
Oh, the shift is huge. The traditional craft approach, like in shop classes Soulcraft, valuing hands-on skill and judgment that still exists, it's vital for restoration and high-end work. But the wider industry, transformed by machines, diamond saws slicing hard granite like butter, multi-axis CNC routers, water jet cutters, the precision and speed are just phenomenal. These machines can do intricate cuts, complex curves, perfect repeats that would be incredibly time-consuming, expensive, maybe even impossible by hand.
Which leads right into the digital revolution, things like building information modeling, BIM, and parametric design software. The sources highlight how revolutionary these are. They seem to be completely changing the possibilities for stone in architecture.
Totally revolutionary. The old way hand drawings, manual stone cutting plans is being replaced. With BIM, you have this detailed 3D digital model of the whole building structure, architecture, services, everything integrated. This lets stone fabricators generate reliable and accurate shop drawings much later in the process, reducing lead times, making them more flexible. And parametric design. Think of complex curving stone facade. Architects can set rules, parameters, and the software generates the complex form. That data can then go straight to the CNC machines. So for the fabricator, it's almost seamless. Architect designs a wild shape in software that gets turned into code for a robot arm or a 5-axis cutter, which carves it precisely out of a slab. This digital precision also cuts down waste, optimizes how you cut the stone, and lets you create unique, bespoke pieces much more efficiently than before. Integrating design and fabrication like this means shapes that used to be unthinkable or just too expensive are now actually feasible in stone.
Frank Gehry's Guggenheim in Bilbao is often cited, right? Even though it's metal, the source mentions how parametric design software enabled those incredibly complex, curving shapes, those irregular and organic forms. The principle seems the same for stone digital tools enabling a kind of formal freedom that was impossible before, pushing stone into totally new territory.
Exactly right. The philosophy behind digitally fabricating metal applies just as well to stone. Architects aren't stuck with just straight lines or simple curves anymore. It's opened up this whole new world of fluid, dynamic stone architecture. And BIM also helps massively with coordination on site. The sources mention enhanced teamwork and coordinating erection at a finer grain. It helps avoid those classic interface problems where different trades clash because their drawings didn't match perfectly. So even putting complex stone pieces in place becomes more efficient, more integrated. It's a complete shift using tech to work with this ancient material in brand new ways.
Okay, but in a world that's increasingly focused on sustainability, green building, where does stone fit in? It's heavy, extraction can be disruptive. It feels almost counterintuitive, doesn't it?
It might seem that way initially, but stone and things made from it can actually be very sustainable, especially if you look at the whole life cycle. Yes, it's heavy, and extraction needs careful management, but consider its durability. One source gives examples like Toyota using ceramic floor tiles from recycled glass and recycled concrete.
showing how stone's derivatives fit into a circular economy. Another mentions a LEED gold level green building, integrating these kinds of material choices strategically. And there's this idea of a closed-loop building material strategy, aiming for materials that are recyclable and buildings that are deconstructible. Stone excels here. Its lifespan is incredibly long. A building standing for centuries doesn't need constant replacement, saving resources over time. That's sustainability in itself. Plus, stone can often be reclaimed from old buildings, cleaned up, reshaped, reused. That cuts down on needing new quarrying. Its thermal mass is also great for passive heating and cooling, reducing energy use. And when you source it locally, you cut transport emissions. So it has strong green credentials, actually.
So even with all the robots and digital design, does the soul of working with stone still come down to human skill? That hands-on connection, does it still matter?
I absolutely believe it does. That idea from shop classes Soulcraft about the complex decision-making and skilled trades, that's crucial. Working directly with a material like stone builds tangible skills, yes, but also fosters problem-solving, a deeper engagement with the physical world. It's not just programming a machine, it's understanding the material's quirks, its voice, coaxing it into shape. That human element, the judgment, the intuition born from experience, feeling the grain machines can't replicate that entirely. They're amazing tools, but they need human skill and intention behind them, often rooted in that primal connection.
Which brings us nicely back around, doesn't it? Appreciating stone as, well, the bedrock of our architectural heritage. It's more than just stuff we build with. It's a record of human effort.
Absolutely. Its permanence is key. It connects us directly to the past, like few other things can. We can still walk through Roman forts, touch medieval cathedral walls, stand in buildings that have seen centuries pass, all because they were built to last, in stone. They're physical history books, tangible links to the ingenuity, the values, the sheer will of those who came before us. You can literally touch history.
And what's really fascinating now is seeing that tension play out, stone's ancient solidity meeting modern digital freedom. It's this ongoing dialogue between the timeless and the cutting edge, shaping our buildings today. Hashtag tag tag outro. Wow, what a journey that was. From the Earth's fiery core right up to gleaming digitally designed structures. We started with that basic human connection to stone, explored its geological roots, igneous, sedimentary, metamorphic, and how that dictated everything. Then we traveled through time, looking at the incredible evolution of craft, from dry stack walls and simple dams to Etruscan arches and soaring cathedrals. Just amazing skill.
Yeah, and we celebrated its enduring beauty, its power as a symbol of authority, identity, culture, but also its importance in everyday buildings, grounding communities in their place. We also faced the real challenges, the weight, the movement, and saw how technology, from the first chisels to today's CNC machines and parametric software, has utterly transformed how we shape and use it. At its heart, it's a story of learning to work with the earth itself, creating shelter, creating meaning, building a lasting relationship with its fundamental material.
This deep dive really hammered home that stone is so much more than just a material. It's a testament to human ingenuity, a canvas for art, a silent witness to our history. It really is the bedrock of our architectural heritage.
And looking ahead, in an age where digital tools promise dynamism, variation, and responsiveness, where buildings might become intelligent agents, it leaves us with a really interesting question, doesn't it? What does the timeless solidity, the inherent permanence of stone, actually mean for us now? For architectural legacy, for our connection to the physical world? Does the soul of a material change just because we can manipulate it in new ways? Or does stone, by its very nature, always anchor us to something deeper, something fundamental, no matter how sophisticated our tools become? Something to think about next time you walk past an old stone wall or a brand new building incorporating it. You're seeing the Earth's enduring gift, shaped by human hands across millennia.